Okay, so we would like to compute the integral of the third power of secant. And here, in order to compute this integral, we should take into consideration that the integral of secant x is equal to ln of absolute value of secant x plus tangent x plus c. Okay? So, so here's what we do. We want to get started with something, right? So we will get started with an integration by parts. And for that reason, we are going to separate secant square from secant, and we will think of secant square as the derivative of tangent. That's the first thing that we need in order to activate an integration by parts. We need to have something which is a derivative of a function, and then we remove the prime and take the product of the two, and we subtract from them the integral where the prime goes over to the other function. And what's the derivative of secant x? The derivative of secant x is simply tangent x times secant x. So here we take tangent square of x that we have in the, let's write it once. And let's recall that the Pythagorean theorem implies that, so we have sine square of x plus cosine square of x is equal to 1. That's the trigonometric form of the Pythagorean theorem. And if we divide through by cosine square, then we have tangent square of x plus 1 is equal to secant square of x. So now you see that tangent square of x is secant square of x minus 1. So this will imply that this is equal to tangent x times secant x minus secant x square of x minus 1 times secant x, which is this integral, right? So we distribute the secant, and we can break this into two integrals. Let's put the integral of the secant first, because we know what it is, and then minus the integral of the cubed third power of secant. And of course, we said that this is ln of absolute value of secant x plus tangent x. And we have minus exactly the integral we started up with. So we're summing up. That's why I'm putting the implication sign. So the integral that we want to find is equal to a function this function minus itself. It's like having one of these equations, x is equal to 4 minus x. What is x? So what do? You bring all the unknowns to the left-hand side. So you have two of them, 2 secant cubed of x dx. You get to this by adding the integral of secant cubed of x to both sides. And now you need to balance things on the right by adding a c. Otherwise, you have on the left something which is many functions, infinitely many functions. On the right, something which is one function. The moment we add that magical c, of course, that imbalance disappears, and then we have eventually this. Oops, over 2. And there's absolutely no need to write C over 2. C over 2 is as generic as C. So we write C. And that is finally the result of our indefinite integration. A very nice example. Thanks for watching.